Today class will start. Man, what's going on?
Start madam. Okay. Good afternoon, dear students. I am Dr. Shivkumar, HOD, Department
Good afternoon,
of
sir.
Mathematics. All are welcome for the induction program. Today I am going to present the fundamentals and importance of the mathematics in the engineering subjects. Okay, before going to start the actual topic, I'm going to introduce my team. Myself, Dr. Shivkumar, HOD, Department of Mathematics, and Dr. A. Rajeshwari, Associate Professor, Department of Mathematics, Dr. Yogalakshmi S., Associate Professor, and Professor Divya S., Assistant Professor, Bhagya CE, Assistant Professor, and Kalpana BR, Assistant Professor. And before going to start the fundamentals and importance, we should see the title and module-wise syllabus of Engineering Mathematics 1, 2, 3, and 4. Now, in the first semester, you have Calculus and Linear Algebra, subject title, and the subject code is 18 Mat 11. In 18 Mat 11, there are 5 modules. The module 1 and module 2 is full of differential calculus. Okay, these 2 modules carries 40 marks. For the differential calculus, we need to know the differentiation in second PUC, limits, differentiation, etc. Okay, limits and continuity, etc. And for the integral calculus, we should know the integral formulas, second PUC integral formulas. I know you people forget all those things. Okay, integral calculus, only 30 to 40% of the students and remember the basic formulas. Remaining 60%, I know that you are forgotten. I will recall everything. Okay, And next model is ordinary differential equation. To solve the ordinary differential equation, we should know both differentiation and integration. And the next model is linear algebra. To learn the linear algebra, you should know the basics on matrix and determinant. That means first semester engineering mathematics 1, that is calculus and linear algebra, is depends on differentiation, integration, and matrix theory. Okay, next one. In the semester 2, we have advanced calculus and numerical methods. This is the continuation of the semester 1 topics. In the advanced calculus, the first module is vector calculus. In the first semester, you have calculus, differential calculus. Along with the differential calculus, we have vectors. Okay, you know what is vector and how to denote vectors. Here in the vector calculus, we have vector quantities with the differentiation. Okay, that is your vector calculus. That means for module 1, you should know vectors, properties of the vectors, and differentiation. And module 2 is differential equation of higher order. Okay, differential equation of higher order means second and higher order differential equation. See, if you know second and higher order linear differential equation, the 80 to 90% of the mechanical and civil subjects depends on this second order differential equations. And that continuation of this differential equation is partial differential equation. I think this partial differentiation is the new topic for you. We will introduce in the nice way, that is same thing, everything is same as differentiation, but here we have 2 or more variables. That's it. The formulas, rules, everything is same as ordinary differential equations and ordinary differentiation. Okay, this is the new topic. And next model is infinite series and power series. You know, series and sequence. Okay, here we have infinite series and power series. This is also a new topic, the continuation of the series and sequence. And the last model is numerical methods. Okay, in the numerical methods, we are going to solve some equation by using some 4 to 5 very important numerical topics. Okay, for these 5 modules, we should know vectors, differentiation, integration, and partial differentiation, series, sequence, and some numerical techniques. Okay, and next, in the next semester, third semester, subject title is Transform Calculus, Fourier Series, and Numerical Techniques. Again, here numerical techniques continue with differential equation. In the second semester, we have only numerical methods, but we are going to apply same numerical methods for the differential equation also. And here, subject title is 18 Mat 3.1. First model is Laplace transformation. Actually, Laplace transformation is a very important topic, especially for the electronics and electrical students. Okay, this Laplace transformation depends on integration with a definite limit. Okay, with lower and upper limits. And the next model is again new topic, Fourier series. This is the continuation of the series and integral part. Okay, in the Fourier series, you are going to solve the problems with integral and series. We are going to find 3 constants a0, an, bn by using different integral formulas. Again, Fourier series depends on integration. Laplace transformation is also depends on integration. Next model is Fourier transformation and Z transformation. This topic is the continuation of the Fourier series, and Fourier transformation is also depends on integral only. That means first 3 models in the mathematics 3 depends on full of integration. You should thorough with all the formulas. Okay, and next model is numerical solution of ordinary differential equation. In the first and second semester, we learn how to solve first order differential equation and the second and higher order differential equation theoretically. But in the third semester, we are going to solve same differential equations by using numerical methods. Okay. In the module 4, we are going to solve first order differential equation using the numerical techniques, and the module 5, we are going to solve second order differential equations by using numerical technique. Okay. Now, come to the fourth semester subject. The title is Complex Analysis, Probability and Statistical Methods. Okay. In the complex analysis, you know what is complex number. Along with complex number, we are going to add differentiation, partial differentiation, integration. Okay. We know how to solve all the problems on differentiation, integration, etc. and vectors also. But here, in the complex analysis, we are going to solve a problem with complex number with variables, complex variables along with differentiation, integration and partial differential equation also. These first two models, calculus of complex functions and conformal transformation and complex integration. This one depends on complex theory, differentiation and integration. And the next model is probability distribution. This is the new topic. You know the basic things in the second PUC, but the next one is the continuation of the same thing, basic probability only. Okay, first two depends on all base differentiation, partial differentiation, along with complex number. But the next three, model 3, model 4, and model 5 depends on full of set theory. Okay, probability distribution depends on set theory. Statistical methods also depends on the set theory and curve fitting. You should know how to draw some curves. Today I'm going to present how to draw 3 curves. That is straight line. You know how to draw the straight line, how to draw circle, a parabola, etc. But the equation is very important. How to write the equation is very important. Okay, I'm going to present after this PPT. And giant probability distribution. This is the set. This is also depends on the model 5. Depends on set theory only. Okay, that means the 1, 2, 3, 4 depends on that is mathematics 1, mathematics 2, 3, and 4 depends on set theory, matrix theory, trigonometry is a must and should. Okay, analytical geometry in a 2 dimension. Analytical geometry in 3 dimension, complex number, and this numerical techniques. Okay. Now I'm going to present the how to draw different curves. Just a few minutes. Are you ready with the notebook and pen? Okay, thank you, Lokesh. Good afternoon, Harsha Shetty, Lokesh. But it's shown Lokesh, man. Puja. Okay. No, not okay. Word kalwa. Word page. ಅಲ್ಲಿ ಬರ್ತದೆ ನೀವು ಬರೆಯೋದಕ್ಕೆ ಪೆನ್ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಇದೆಲ್ಲ ತಗೊಳ್ಳಿ. ಅವಾಗಲೇ ಇಲ್ಲಿ ನಾವು ಅದು ಡಿಫ್ರೆಂಟ್ ಫೀಲ್ ಬರ್ತಾ ಇದೆ.
Once
ಈಗ ಸೀಟ್ ಅಲ್ಲ ಅದೇ ಥರ ಒಂದು 10 ಸ್ಲೈಡ್ ಹಾಕ್ಬಿಟ್ಬಿಡಿ. ಅರ್ಧ ಗಂಟೆ ಊಟ ಮಾಡಿಸ್ಬೇಕು ಮತ್ತೆ Okay, just wait for me. Please ಮಾಡಲಾ? Okay. pen ತಗೊಂಡೆ. ಕಲರ್ ನೋಡಿ. ರೆಡ್ ಬ್ಲಾಕ್ ರೆಡ್ ಬ್ಲಾಕ್. Okay. Okay, ready. Okay, am I audible, students? Rubber.
Yes, sir.
Yes,
Now,
sir.
we are going to explain how to draw straight line. Everybody knows that how to draw straight line. If we ask draw a straight line, everybody draw like this. Okay, this is one of the straight line. Next one is perpendicular to the previous one. Next one is this one. This one. Okay, here I draw 4 straight lines. First one is sleeping line. Second one is a standing line. Third and fourth straight lines are with some slopes. Okay. Now, the drawing the straight line is very easy. But what is the equation of
Sir,
these?
did you on the camera?
Is very important in the engineering subjects. Okay. So in the engineering subjects, the 80 to 90% of the some subjects, that is mechanical and civil subject, depends on mathematics only. Next, 60 to 70% of the subjects in electrical and electronics depends on mathematics only. And in IS and CS, almost 50% of the subjects depends on these basic things, mathematics. Okay. Now, I'm going to explain about the first line, sleeping line. See, first line is, next slide. Okay. Next one. This is your straight line. Okay. I will fix coordinate axis.
Sir, we can't see anything.
Okay. This is your origin. And this is your x-axis. This one is your y-axis. What is the equation of x-axis? Equation of x-axis is y is equal to 0, because along x-axis, y coordinate is always 0 from this point to this point. That means from -infinity to +infinity, along x-axis, y is always 0, because, and therefore the equation of x-axis is y is equal to 0. Similarly, come to the y-axis. The equation of y-axis is x is equal to 0, because from -infinity to +infinity, x value is 0 along y-axis. Okay. Now I will extend this line, first line. I will extend this like this. Okay. I will call this distance as A. Okay. Here, what is A? X is equal to, I'm taking this is x is 0, y is equal to 0. Along x-axis, I took 1, 2, 3, 4. X is 1, 2, 3, 4. Y is always 0. Similarly, I will divide this one into 1, 2, 3, 4. Okay. Instead of A, I'm taking 1, 2, 3, 4. This straight line passing through 2 at the point 2. At this point, what is the coordinates? Along y-axis, x is 0 and y coordinate is 2. Therefore, equation of this line is x is equal to 2. Okay, suppose a straight line passing through this point 0, 1. Then what is the equation of this line? Equation of this line is x is equal to 1. Okay, these two lines are parallel to x-axis. Okay, similarly, the line passing through 0, 3 is x is equal to 3. And now I'll come to the standing line. Okay, these are all sleeping lines with the slope 0. Sleeping lines are always parallel to x-axis only, and equation is in terms of x only. X is equal to 1, x is equal to 2, x is equal to 3, etc. In general, x is equal to a. Okay, similarly, suppose these lines are passing through the negative points, that is somewhere here. This is your -1, -2, -3, etc. And what is the coordinate of this point? X is was 0, y is -1. Therefore, this one. Okay, so x is equal to, oh sorry, I am teaching in different way. Oh, sorry, this is y, not x. Sorry. These are all y. Y is equal to 2, y is equal to 3, etc. In general, y is equal to a. Okay, and here y is equal to -1. If you draw a straight line passing through 0, -2 is y is equal to -2, etc. Okay, now I'll go to the next line, that is the line. Sorry, next page. ಬರ್ತಾ ಇಲ್ವಲ್ಲ, ಓದ್ತಾ ಇಲ್ಲ ಪ್ರೊಫೆಸರ್. No. Okay. Now I will take y-axis and x-axis. Okay. Now I will take the parallel.
Sir, I can't see anything. Is there a problem?
Previous lines are in terms of y. In the first 4 lines, I took different one, that is x, not x, y. Y is equal to 1, 2, 3, 4, etc. Okay. This is your x-axis. This is your y-axis. Okay. And what is the equation of y-axis? X is equal to 0, and the equation of x-axis is y is equal to 0. This is your coordinate. If you take this one as point, that is x is equal to 1 and y is equal to 0, then equation of this straight line is x is equal to 1. Okay, and equation of this line is, suppose if it is 2, 0, x is equal to 2. Okay, similarly, this one is x is equal to 3, x is equal to 4, etc. Okay, and negative side of the x-axis, if it is -1, -2, -3, etc., the equation of these straight lines parallel to y-axis is x is equal to -1, x is equal to -2, x is equal to -3, etc. This is about a sleeping line and a standing line. That is, sleeping line is parallel to x-axis, standing line is parallel to y-axis. Okay, and now I will come to the line with the slope, this line. Okay, now I will fix a coordinate axis somewhere here. Okay, this is your origin, x-axis, y-axis. Now see the point of intersection, this point of intersection of straight line and y-axis, this distance I will take it as c, and this line touches the y-axis, means in the left hand side we get y. Okay, is equal to mx plus c. What is c here? C is the y-intercept. Okay, and how do you find m? By using m is equal to tan theta. By using the angle between this line and x-axis, we can take slope. M is always tan theta. Find the slope of this line by using m is equal to tan theta and substitute here. Okay, this is the general form of slope intercept form of the equation of the straight line. This line is very important throughout the engineering field. You use this line y is equal to mx plus c. Suppose for same line, sleeping line, you take here. If we fix a coordinate axis here, this is our origin. Okay, y-axis. This is your x-axis, origin, and this is your y is equal to 0, x is equal to 0 is the equations of x and y-axis. Now, what is the y-intercept in this line? Y-intercept here, y-intercept is c, but in this line, y-intercept becomes 0, c becomes 0. Okay, that means c is equal to 0 here. Then y is equal to mx plus c. Y is equal to mx plus c becomes y is equal to mx only, because this line is passing through the origin. Okay, there is no y-intercept. Now come to the angle. Here angle is 45 degree. Okay, now find the slope. Y is equal to mx. Here m is tan theta. Tan 45 is 1. Therefore, the equation of this line is y is equal to x. Okay, next. Suppose if I fix a coordinate axis for same line. For same line, I will fix the coordinate axis somewhere here. Okay, this is our origin, x-axis, y-axis. Okay, see the point of intersection here. I am taking, this is your 0 comma a, this one is 0 comma, sorry, b comma, x is b, here x, sorry, this one is a comma 0, this one is, sorry, ರಬ್ಬಣಕ್ಕಾಗ್ತಾ ಇಲ್ಲ ಎರೇಸರ್ ತಗೊಳಕ್ಕಾಗ್ತಾ ಇಲ್ಲ, ಅದೇ ಪ್ರಾಬ್ಲಮ್ ಆಗಿರೋದು. ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್ ಬಿಡಿ. ನೋ ಆಯ್ತು ಬಿಡಿ. ದಿಸ್ ಇಸ್ 0 comma b. ಓಕೆ, ಆಗ್ತಾ ಇಲ್ಲ. ಇಲ್ಲ. Okay, here this is negative side of the x-axis. Therefore, this distance is the minus a from 0 to a. Here, y coordinate is plus b. Okay, positive side of the y-axis. Now, to write this equation of this straight line, take x. General form of the intercept form of the straight line is x by a plus y by b is equal to 1. Now, since x is here negative a, take x by minus a. X is negative here. And b, y is positive. Y by b is equal to 1. Therefore, equation of this line is x by minus a plus y by b is equal to 1. Okay. Suppose if I fix for same line, if I fix coordinate here, this is your origin. 0 comma 0, here x is positive, a comma 0, here y is negative. Okay, 0 comma b, this distance is say minus b, this one is minus b. Okay, now what is the equation of this line? Using the same general form x by a plus y by b, the equation of this line can be written as x by a plus y by minus b is equal to 1. That is x by a minus y by b is equal to 1 is the equation of this line. Okay. Now I'll come to the next line. Yeah, this one. Okay. Okay. Now I will fix the coordinate axis somewhere here. This is your y-axis. Rubber ಸಿಗ್ತಲ್ಲ professor. Okay. This is your origin 0, 0, x-axis, y-axis. Okay. Now here the slope is negative. Same as y is equal to x. This line is y is equal to x. The opposite to that line slope is -1. Therefore, equation of this line is y is equal to minus x. Okay. Now for the same line, if we fix the coordinate axis like this with origin 0, 0, this is your negative side of the y-axis. This is your negative side of the y-axis. Both are negative here. X is minus a, here. This distance is minus b. Therefore, what is the equation? X by minus a plus y by minus b is equal to 1. Therefore, x by a plus y by b is equal to -1 is the equation of this line. And what is the equation of this line? Y is equal to minus x. Okay. Next. Okay. These are all some different types of the straight lines. Now we'll come to the parabola. Okay. In general, y square is equal to 4ax is the equation of the parabola. Okay. Now I am neglecting this constant. This constant may be anything. Just I am taking y square is equal to x. Okay. How to draw this y square is equal to x? Okay. See, in parabola, if we have even powers, in y, this curve is symmetrical about x-axis. Okay. Now I'm taking this coordinate axis. Y is equal to x and x is equal to 0 and y is equal to 0. This is your 0, 0. Okay. Now this parabola is symmetrical about x-axis because we have even power in y. Okay. And its face is towards positive side of the x-axis, passing through the origin. Okay, y square is equal to x is a parabola symmetrical about positive x-axis because here sign is positive, plus x. Okay, suppose if it is like this, y square is equal to minus x. Is also a parabola. We have even power in y, and this is symmetrical about x-axis only, but here we have negative sign. Its face is negative side of the x-axis like this. Okay. Therefore, equation of this parabola is y square is equal to minus x, and equation of this parabola is y square is equal to plus x. Okay. And we have, see, y square is equal to plus x is a parabola. You know how to draw this parabola. It is like this. Okay. Suppose the parabola is like this. Y square, equation is y square is equal to a plus x. Okay. If it is a plus x, take y-axis and x-axis. Okay. Y square is equal to x is symmetrical about x-axis and facing towards positive x-axis. Here also it is same positive x-axis only. Along with x, we have some constant a. That means x is equal to a. I will take this point here as a. Okay, x is a, y is 0. Y square is equal to a plus x is a parabola. It is passing through a comma 0. It is passing through a comma 0 and facing towards positive x-axis. Now see the difference between y square is equal to x and y square is equal to a plus x. Y square is equal to x is passing through the origin, that is 0, 0, and y square is equal to a plus x is passing through a, 0. Okay, and if it is like this, y square is equal to minus a plus x. Okay, that is, take y-axis, x-axis. X is minus a means this point. Okay, minus a, 0. Okay, now we have plus x, minus a, 0, and we have positive x. That means it is passing through minus a, 0 and facing towards positive x-axis only, like this. Okay, next. See the difference between these three curves. Y square, y square, y square, u1 power in x only. That means it is symmetrical about x-axis. And we have plus x, plus x, plus x towards positive x-axis only. And here it is passing through 0, 0, passing through a, 0, and passing through minus a, 0. Okay. Next one is y square is equal to minus x. Okay, y square is equal to minus x. How to draw this parabola? Passing through origin only, and it is passing through origin, facing towards negative side of the x-axis. Okay, symmetrical about x-axis, and we have negative sign facing towards negative side of the x-axis. Now, if it is like this, y square is equal to a minus x. Okay, y-axis, x-axis. Now y square is equal to plus a. That means it is passing through a, 0 only, and we have negative sign, means facing towards negative side of the x-axis. It is like this. Okay, y square is equal to a plus a minus x. If it is y square is equal to minus a minus x, then take y-axis, x-axis. We have minus a. I will take this point as minus a, 0. Okay, and we have minus x, negative side. X symmetrical about y-axis because we have u1 power in y, and we have minus a passing through minus a, 0, and we have minus x symmetrical about x and facing towards negative side of the x-axis. Next one is x square is equal to y. See, x square is equal to y is same as y square is equal to x. Here we have e1 power in x. If we have e1 power in x, it is symmetrical about y-axis. Okay, how do you draw this parabola? Take coordinate axis. Okay, e1 power in x symmetrical about y-axis, and we have plus y, means it is facing towards positive side of the y-axis, like this. Okay, and if it is like this, x square is equal to minus y. In this case, we have u1 power in x. That means symmetrical about y-axis only, and we have minus y. That means it is symmetrical about y-axis, facing towards negative side of the y-axis, passing through this 0, 0 only. Okay, now I will take x square is equal to y. X square is equal to y. X square is equal to y can be written as like this, symmetrical about y-axis and passing through 0, 0. If you take x square is equal to a plus y, okay, a plus y. Here we have y, that means this value, this coordinate is also belongs to y only. Y is a. I will take this point as a. This is 0, comma a. X is 0, y is a. And we have plus y. That means it is facing towards positive y-axis. Okay, since we have even power in x, it is symmetrical about y-axis and passing through 0, comma a and plus y faces towards positive y-axis. Okay. Next, we have x square is equal to minus a plus y. Okay, it is minus a plus y, a coordinate axis. Y is minus a, this point, 0, comma minus a. Okay, and we have plus y means its face is towards positive y-axis like this. Okay, this parabola is passing through 0, comma minus a, and it is symmetrical about y-axis because we have even power in x. Okay, similarly, I will take x square is equal to minus y. Okay, x square is equal to minus y is like this. Even power in x, symmetrical about y-axis, and we have negative side, that is y symmetrical about y-axis and facing towards negative x-axis because we have negative sign. Okay, and x square is equal to a minus y. Take coordinate axis like this and plus a, 0, comma plus a, this one. This is your zero, comma a, and we have minus y. It is symmetrical about x-axis facing towards negative side of the y-axis like this. And x square is equal to minus a minus y. If it is x square is minus a minus y, symmetrical about y-axis only because we have even power in x, and minus a, 0, comma minus a. Okay, and we have minus y facing towards like this, downwards, facing towards negative side of the y-axis. Okay, these are all the different types of parabolas. Okay, now next one, I will come to the circle. X square plus y square is equal to a square. See, x square plus y square is equal to a square is a equation of the circle passing through the origin. Okay, how do you draw the circle? Circle with the center 0, comma 0. Now, in this circle, we can choose a different region. Okay, suppose for same circle, x square plus y square is equal to a square. If x is 0, x square plus y square is equal to a square. In this circle, we have to select the region x is greater than 0. Okay, x is greater than 0 means if it is like this, circle, x is positive quantity, that means this region. Okay, how do you select the region? By using x greater than 0 and less than 0. If it is x is greater than 0, positive x-axis. Okay, this side. If it is like this, x is less than 0, then what is your region? X less than 0 means this one, this side. Okay, next one. In the same circle, x square plus y square is equal to a square. If y is greater than 0, then what is your region? This is your circle. Y greater than 0 means y is positive side, this side, above x-axis. Okay, and x square plus y square is equal to a square if y is less than 0. What is your region in this case? Y less than 0 means this region. Okay, now next thing is same circle only. We have to select a region which is x is greater than 0 and y is greater than 0. Both x and y are positive. Okay, now this is your coordinate axis. Circle with center 0, 0. X is positive, y is positive. This means x is greater than 0 means this region, and y is also greater than 0 means this one. This one. Okay, positive quadrant. Next, suppose if it is like this, x square plus y square is equal to a square. X is greater than 0, y is less than 0. Okay, then what is your region? X-axis, y-axis. Circle with center 0, 0. X is positive means this side. X is positive side and y is negative side, this one. Fourth quadrant of the circle. Okay, x is positive, y is negative. And x square plus y square is equal to a square is a equation of the circle with x is less than 0, y is greater than 0. Okay, x is negative, y is positive. Then what is your region? Circle, center 0, 0. X is negative side, this side, and y is positive side, this one. Okay, next one is x square plus y square is equal to a square. X is less than 0 and y is also less than 0. Both are negative side. Okay, that means the region is x is negative side, this side, and y is also negative, this one. Okay, now you got the idea about how to draw a straight lines and corresponding equations, and how to draw a parabola and respected equations, and how to draw a circle with how to select the different region in the circle. But after all these things, you should know how to find the limits for x and y. Okay, actually we can find two types of limits. I will take a circle, same thing, x square plus y square is equal to a square. Okay, and I will take x is greater than 0, y is greater than 0. In this region, we can find two sets of limits. Okay, first I will draw the region here. Okay, according to this condition, x is greater than 0 and y is greater than 0. What is your region? X is greater than 0 means this one, positive side of x-axis and positive side of y-axis. In this region, we have to find the limits. Okay, we can find two sets of limits, set 1, set 2. Okay, in the set 1, I will take constant limits for x and variable limits for y. Similarly, in the set 2, we can find constant limits for y and variable limits for x. Before going to find the set 1 and set 2, you should know how to find the constant limits and variable limits for x and y. Okay, In this circle, this is your origin 0, 0, and this is a, 0. X is a, y is 0. That means this radius is a. Okay, and y coordinate along y axis, x is 0, y is a, radius is a only. Okay, to find the constant limit. Okay, in the set 1, that may be set 1 or set 2, for one variable limit should be constant, for other variable limit should be in terms of variables. Okay, in terms of x it is y, in terms of y it is x. Okay, now to find the constant limit for x, set 1, to find a constant limit for x, draw a line along x-axis. This one, draw a line along x-axis. Okay, here lower limit lies on origin 0, 0. That is, lower limit is always the left side, upper limit is right side. Okay, lower limit is 0, 0. That means at this point, what is x? X is 0 here. Okay, next, and here what is x at this point? X is a. This is your upper limit, this is your lower limit. X is a. That means x varies from 0 to a. X varies from 0 to a. Okay, now for x we have constant limits. Now we have to find variable limits for y. How do you find the variable limits? Before going to find the variable limits, draw variable limits for y. Draw a straight line. Draw a straight line parallel to y-axis within a region. Very important. Draw a straight line parallel to y-axis within a region. Here lower limit lies on x-axis, upper limit lies on the circle. Okay, along x-axis y is 0. That means lower limit for y is 0. Okay, now come to the upper limit. Upper limit lies on what? Circle. Then what is the equation of the circle? X square plus y square is equal to a square. Is the equation of the circle. From this equation, find y. Okay, what is y? See, y square is equal to a square minus x square. Then y is equal to plus or minus square root of a square minus x square. We get 2 points. Y is equal to plus the square root of a square minus x square, and y is equal to minus square root of a square minus x square. Okay, here the upper limit lies on the first quadrant. In the first quadrant, both x is positive and y is positive. That means you have to take this limit because it is positive. In the first quadrant, y is positive. Therefore, y varies from 0 to square root of a square minus x square. This minus the square root of a square minus x square is opposite side, this point. Okay, lies on circle only, but it lies on fourth quadrant. Okay, now the y varies from 0 to upper limit is square root of a square minus x square. Similarly, we can find the constant limits for y and variable limits for x. Okay, now for the same circle, same region, we can find the constant limits for y. How do you find the constant limits for y? Draw a straight line along y-axis. Okay, if you draw a straight line along y-axis here, ಪೆನ್ನೆಲ್ಲ ಹೋಯ್ತು ಮೇಡಮ್ ಇದು. ಓಕೆ, ರಬ್ಬರ್ ಹೋಗ್ತಾ ಇಲ್ಲ. ರಬ್ಬರು ಅದೇ ಪೆನ್ ಬರ್ತಾ ಇಲ್ಲ. Okay. Draw a straight line along y-axis. Okay. Lower limit lies on x-axis. Upper limit lies on a circle only. But at this point, y is a. Okay. Here, y is 0. At the coordinate, y is 0. And since radius is a, along y-axis, y is a only. Therefore, the constant limits for y is 0 to a. Okay? And now we need to find the variable limits for x. How do you find the variable limits for x? Same as previous one. To find the variable limits for x, draw a straight line parallel to x-axis. This one. Okay. Lower limit lies on y-axis. Upper limit lies on a circle. Along y-axis, what is x? X is 0. Therefore, lower limit is 0. Okay. Now come to the upper limit. Upper limit lies on a circle. Okay. What is the equation of the circle? X square plus y square is equal to a square. Okay, by using this equation, we can find x. What is x? See, x square is a square minus y square. X is plus or minus square root of a square minus y square. Here, we get 2 points. X is plus square root of a square minus y square, and x is equal to minus square root of a square minus y square. Okay, since this region is bounded in the first quadrant, we have to take plus. Okay, that means x varies from square root of a square minus y square. Okay, minus square root of a square minus y square is this side, somewhere here, negative side of the y-axis. Okay, like this, we can find 2 sets of limits for any region in the different curve. Here, I am taking example in the circle with x is greater than 0 and y is greater than 0. Similarly, if you select a circle, x is greater than 0, only x is greater than 0, this one. Okay, in this region also we can find 2 sets of limits. What is the equation actually? X square plus y square is equal to a square is the equation of a circle. Okay, here x is greater than 0. This region is x is greater than 0. Now, this is your origin, a comma 0, 0 comma minus a, sorry, 0 comma a, this one is 0 comma minus a, and minus a comma 0. Radius is a only. Radius is a. Now, in this region also, we can find 2 sets of limits. Okay. Now, set 1, constant limits for x and variable limits for y. Set 2, constant limits for y, variable limits for x. Okay. Now, how do you find the constant limits for x? Draw a straight line along x-axis in the region. This one. Okay. Here x-axis varies from origin to A. That means x is equal to 0 is the lower limit, x is equal to A is the upper limit. Then x varies from 0 to A. Okay, next we have to find variable limits for y. How do you find the variable limits for y? Draw a straight line parallel to y-axis in the region. Draw a straight line parallel to y-axis. Lower limit lies on circle and upper limit is also lies on the circle. Okay. Now, both upper and lower limit lies on the circle. Okay. By using the equation of the circle, x square plus y square is equal to a square, we can find lower and upper limit. Okay. Now, first find y. So y square is a square minus x square. Then y is plus or minus square root of a square minus x square. Then we get 2 points. Y is equal to plus square root of a square minus x square, and y is equal to minus square root of a square minus x square. Okay. See, plus square root of a square minus x square is this point. This is your plus square root of a square minus x square, and this one is plus minus square root of a square minus x square. That means lower limit is minus square root of a square minus x square. To upper limit is plus square root of a square minus x square. Okay. Now, similarly, we can find constant limits for y and variable limits for x. Okay. How do you find the constant limits for y? Draw a straight line along y-axis. This one. Draw a straight line along y-axis. To find the constant limits, always we should draw a straight line along coordinate axis. Okay. No, for the x-axis, draw a line along x-axis only. For y, constant limits for y, draw a straight line along y-axis only. Okay. Here, y varies from this point to this point. Okay. Here, y is minus a at this point. Therefore, I will take here. Y is minus a to y is equal to plus a. Lower limit is minus a, upper limit is plus a. Okay. Therefore, y varies from minus a to plus a. Minus a to plus a. And we have to find the variable limits for x. Okay. How do you find the variable limits for x? Draw a straight line along x-axis. Okay. In the region parallel to x-axis. Along x-axis, constant limits. For variable limits, draw a straight line parallel to x-axis anywhere in the region, somewhere here or here, etc. Okay. Now I am taking a line in this point. Lower limit lies on y-axis, upper limit lies on a circle. Okay. Lower limit lies on y-axis means x is what? 0 only. Along y-axis, x is 0, and upper limit lies on a circle. Okay. Using the equation of the circle, we can find x square plus y square is equal to a square. We can find x. X is square root of a square minus x square. Is plus or minus square root of a square minus x square. Next is plus the square root of a square minus x square. And x is minus the square root of a square minus x square. Since region is bounded in the positive side, x is plus square root of a square minus x square. Therefore, x varies from, sorry, a square minus, sorry, this is y. Y square. Okay. X varies from 0 to square root of a square minus y square. Like this, we can find set of limits, two sets of limits for any region. Okay, this is the simple example. But I am explaining with the circle. Now, I'm taking a parabola. Okay, parabola, this one, and a region bounded by two curves. This is your y is equal to x. Okay, a straight line passing through origin with an angle 45 degrees, y is equal to x. And what is the equation of this parabola? Symmetrical about y-axis means x square is equal to y. Okay, x square is equal to y. Now, we have to find the limits in this region. See, last example is for finding the lower and upper limits in a circle only one curve along with coordinate axis. But here we have two curves, straight line and parabola along with coordinate axis. Okay, this is your origin, and this parabola is x square is equal to y, and the equation of straight line is y is equal to x. First, we have to identify 4 points. If you have 2 or more curves, first identify the 4 points. The 4 points are one with origin, and the next one at the point of intersection, draw a straight line parallel to x-axis and a straight line parallel to y-axis, like this. Okay, now we can find 4 points here. Okay, one is with origin 0, 0. Now, first we have to find the point of intersection of this point of intersection of straight line and parabola. How do you find the point of intersection of straight line and parabola? Substitute one curve in the other curve. That's it. We have x square is equal to y. Okay, now put y is equal to x in this parabola. That means x square is equal to, put y is equal to x. We get x. Okay, then x and x gets cancels. Then what is x? X is 1 only. Therefore, x coordinate is 1. Now, if you put x is equal to 1, we can find y coordinate in any curve, either parabola or straight line. If you put x is equal to 1 in a straight line, y is equal to x. If you put x is equal to 1, then y is also equal to 1. Therefore, y coordinate is 1. Or we can put x is equal to 1, x square is equal to y is the parabola. Put x is equal to 1 here. 1 square is equal to y, then y is equal to 1 only. You get same coordinate. Okay, therefore, coordinates of the point of intersection of a straight line and parabola is 1, 1. Okay, if it is 1, 1, then what is the coordinate of this point? That is a straight line parallel to y-axis and x-axis. This one, x-axis. Equation is y is equal to 0. Then y coordinate is 0 only. Now what is x coordinate? This one, 1, 0. Similarly, along y-axis, x is 0 always. Okay, x is 0. X coordinate is 0. What is y coordinate? Already we find y value. Same thing. Now, can you tell me the equation of these two straight lines? See, this straight line is passing through 1, 0 means x is equal to 1. Okay, and then what is the equation of this line? Y is equal to 1. Okay, that means region is bounded by 4 straight lines. This one, y-axis, that is x is equal to 0, and a straight line parallel to y-axis, that is x is equal to 1. And region is bounded by x-axis, that is y is equal to 0 and y is equal to 1. Okay, now we can find two sets of limits in this region. Set 1. In the set 1, we have to find the constant limits for x and variable limits for y. Okay, how do you find the constant limits for x? Draw a straight line along x-axis. Draw a straight line along x-axis. Actually, this region is bounded between these two straight lines. Okay. Now, to find lower limit, left side, consider left side of the point and consider the right side point to find the upper limit. Okay. Therefore, x varies from this point to this point. Okay. X varies from at this point. What is x? X is 0. And at this point, what is x? X is equal to 1. That means region is bounded between y-axis and x is equal to 1. Therefore, x varies from 0 to 1. Now, next one is very important. We have to find the variable limits for y. Okay. How do you find the variable limits for y? Draw a straight line parallel to y-axis within a region. Always we should choose within a region to find the variable limits. Okay. Now, lower limit lies on parabola, upper limit lies on a straight line. What is the equation of this parabola? X square is equal to y. Okay. Using x square is equal to y, we can find lower limit for y. See, x square is equal to y. This implies, what is y? Y is x square. Therefore, lower limit is x square. Now come to the upper limit. Upper limit lies on a straight line. Okay, upper limit lies on a straight line. What is the equation of the straight line? Y is equal to x. Okay, or x is equal to y. Y is equal to x. Therefore, variable limits for y is x square and x. Lower limit is x square, upper limit is x. Similarly, we can find set 2. Okay, in set 2, we can find constant limits for y and variable limits for x. Okay. How do you find the constant limit? Draw a straight line along y-axis. Here. Draw a straight line along y-axis. Okay. Lower limit lies on x-axis 0, 0 and upper limit lies on 0, 1. Therefore, y varies from 0 to 1. Y varies from 0 to 1. Now, come to the variable limits for x. How do you find the variable limits for x? Draw a straight line parallel to x-axis. Okay? Draw a straight line parallel to x-axis. Okay? Now, lower limit lies on a straight line. Left side point is your lower limit. Right side point is your upper limit. Okay? Now, lower limit lies on a straight line. What is the equation of straight line? Y is equal to x. Okay? Y is equal to x is your straight line. Then this implies, what is x? X is y only. Y is equal to x implies that x is equal to y. Therefore, lower limit is y. Okay? Now come to the upper limit. Upper limit lies on parabola. That is x square is equal to y. From this equation, find x. What is x? X is plus or minus square root of y. Okay, that is x is equal to plus y, x is equal to minus root y. Okay, since this region is bounded in the first quadrant, consider plus root y. Okay, this minus root y is negative side of the x-axis, this side, opposite side. Okay, the next varies from y to root y. Like this, we can find the two sets of limits for all the region by using different curves. Okay, but in the engineering field, in M1, M2, M3, M4, in all the most of the subjects, we use straight line, circle, and parabola. Okay, now this is about the curves. Now, next one is indices. In the indices formula, you know what is A into B power M, A by B power M, or A power M into N, etc. But I am not going to explain all those things. I will explain only the important formulas. You know that all the things, but you have some confusion about some formulas. Okay, I'm going to explain those things. See, what is A power 0? All of you know that A power 0 is 1. How do you remember this? Anything to the power 0 is 1, correct? But that is wrong concept. Anything to the power is not equal to 1. That depends on A value. Suppose A is equal to 0. What happens? And if A is equal to infinity, what happens? That is infinity. If A is 0, what is A power 0? And if A is infinity, what is A power 0? Okay, these two are very important. You remember this formula as anything to the power of 0 is 1, but that is wrong one. Suppose if A becomes 0, we get 0 power 0, but 0 power 0 is not equal to 1. Similarly, if A becomes infinity, infinity power 0 is also not equal to 1. Then what about these two things, A power 0 and infinity power 0? These two, A power, that is 0 power 0 and infinity power 0, do not represent any real number. Do not represent any real number. Okay, actually there is a separate concept called as indeterminate forms. Okay, there are 7 indeterminate forms. Out of 7 indeterminate forms, these two are the 2 forms. Okay, actually we have 5 more indeterminate forms. While explaining the indeterminate forms, I will explain how to convert into the, how to find these, how to find the real values for these expressions. Okay, next one is, you know what is log 0? You know what is log 0? And log infinity. We use these two formulas almost in the mathematical subject in M1 and M2, engineering mathematics 1 and 2. What is log 0? Log 0 is minus infinity. And what about log infinity? Log infinity is infinity. Both are infinity only. Log 0 is negative side, log infinity is positive side. Okay, next. You know what is 1 by 0? Yes, what is 1 by 0?
1.
Yes, 1 by 0 is infinity.
Infinity.
And 1 by infinity, 1 by infinity is 0.
0.
Okay, by using these concepts, I'm going to explain what about 0 by 0 and infinity by infinity. You know what is 0 by 0? See, 1 by 1 is 1, 2 by 2 is 1, 3 by 3 is 1, etc. Okay, what about 0 by 0? 0 by 0 do not represent any real number. Similarly, infinity by infinity is also do not represent any real number. These two are also indeterminate forms. Madam? ಅದು ಏನು ತೊಂದರೆ ಇಲ್ಲ. ಓಕೆ ಸರಿ ಮೇಡಮ್, ಅಲ್ಲಿ ನಮ್ಮ ಫ್ಯಾಕಲ್ಟಿಗೆ ಒಂದೊಂದು ಮೀಟಿಂಗ್ ಡೈರಿ ಇದೆ ತರ ಕೇಳ್ತೀರಾ? ಅಲ್ಲಿ ಇರ್ತಾರೆ ನೋಡ್ರಿ. ಓಕೆ, 0 by 0 and infinity by infinity are also do not represent any real number. Therefore, these two are also the indeterminate form. Okay, now next one is, you know what is 1 power n? 1 power n is 1 only. 1 power n is 1 only. If n is equal to 0, if n is equal to 0, what happens? That is 1 power 0 is 1. If n is equal to 1, 1 power 1 is 1 only. If n is equal to 2, 1. If n is equal to 3, 1, etc. But what about 1 power infinity? See, 1 power n is 1, 1 power 1, 1 power 2, 1 power 3, etc. becomes 1 only. But if it is 1 power infinity, what happens? Okay,
Infinite.
this is also do not represent any real number. Okay, the exponential form, these 0 power 0, infinity power 0, 1 power infinity. These three are exponential forms in the indeterminate form. Okay, now next one is, you know what is 1 minus 1? Okay, 1 minus 1 is 0 only. 2 minus 2 is also 0, etc. If it is infinity minus infinity, what happens? If it is infinity minus infinity, blue color ಹೊಸ diary. ಈ ಮೀಟಿಂಗ್ ತಗೊಂಡೋಗ್ತಾನೆ ಅದು. Infinity minus infinity, what happens? Okay, see, we can write infinity as 1 by 0. Here also, same thing. 1 by 0. Okay, if we take LCM, 0 minus 0 by 0, that is equal to 0 by 0 only. Okay, see, 0 by 0 is a indeterminate form. Therefore, infinity minus infinity is also indeterminate form. Okay, and you know what is 1 into 0? 1 into 0 is 0, and 2 into 0, that is 0 only. What about infinity into 0? Yes, the infinity into 0 is, I will write infinity as 1 by 0. This infinity as 1 by 0 into 0. That is 1 into 0 is 0, 0 by 0. Therefore, infinity into 0 is also indeterminate forms. Okay, that means infinity minus infinity and 0 into infinity, we reduce these two forms into 0 by 0. Okay, therefore, these two are the indeterminate ಫಾರಮ್ಸ್. ಬೇರೆ ಇಟ್ಟಿದ್ದೀನಿ ನೋಡಿ ಮೇಡಮ್, ಚಿಕ್ಕ ಡೈರಿ, ಈಸ್ಟ್ ವೆಸ್ಟ್ ಯೂನಿಟ್ ಆಫ್ ಟೆಕ್ನಾಲಜಿ ಅಂತ ಪ್ರಿಂಟ್ ಆಗಿದೆ ಬೇರೆ. ಓಕೆ, therefore see 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity are the indeterminate forms. Okay, anything if it is convert into the 0 by 0 form, that is always indeterminate forms. Okay, but in this case, ಏನಾಯ್ತಲ್ಲ ಮೇಡಮ್ ನೋಡಿ, ಡಿಸ್ಕನೆಕ್ಟ್ ಆಯ್ತಾ ಅಂತ. ಓಕೆ, ಬಂತು ಬಿಡಿ. ಸ್ಲೈಡ್ ಖಾಲಿ ಆಗ್ಬಿಟ್ಟು ಒಂದು ನಿಮಿಷ. ಸ್ಲೈಡ್ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು ಅನ್ಸುತ್ತೆ. ಓಕೆ, ಪೆನ್ನು ಎಲ್ಲೋ ಇತ್ತು. 0 by 0, infinity by infinity, infinity minus infinity, infinity into 0, or 0 into infinity. These are the 4 indeterminate forms. Okay, and we know what is log 0 is minus infinity, log infinity is plus infinity. Now I'll come to the 0 power 0. Okay, I will take this one as y. Y is equal to 0 power 0. Now I will take log on both sides. Log 0 power 0. By using the properties of the logarithm, log 0 power 0, log a power b can be written as b into log a. Similarly, log 0 power 0 becomes 0 into log 0. But what is log 0? 0 into log 0 is minus infinity. Okay, no need to worry about this sign. This is also the indeterminate forms. Okay, in indeterminate form, that may be negative sign or positive sign. That is negative infinity or positive infinity. 0 into infinity is indeterminate form. Therefore, 0 power 0 is also becomes indeterminate forms. Okay, similarly, infinity power 0. Okay, if it is infinity power 0, take it as y. Y is equal to infinity power 0. Now take log on both sides. Log y is equal to log of infinity power 0. Now use this property b log a. 0 into log infinity. But what is log infinity? Infinity only. But 0 into infinity is indeterminate forms. Therefore, infinity power 0 is also indeterminate forms. Similarly, I will take 1 power infinity. Okay, take y is equal to 1 power infinity. Then take log on both sides. Log y is equal to log 1 power infinity. That is infinity into log 1. But what is log 1? Log 1 is 0. Okay, therefore infinity into 0 is also indeterminate form. That is 1 power infinity or the indeterminate. Now these 7 cases are the indeterminate forms. These 7 cases do not represent any real values. Okay, to solve the mathematical expressions like 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, or infinity into 0, 0 power 0, infinity power 0, and 1 power infinity, we use L'Hospital's rule. Okay, we will explain L'Hospital's rule in depth in the classroom. Okay, just remember these 7 cases are the indeterminate forms. Okay, now I'm going to explain the Pascal triangle. Okay, this triangle is used to find the coefficients in the binomial theorem. Okay, this is very, very important triangle. We use this triangle to find the coefficients of the binomial theorem. Okay, I'm taking this line. Now I'm taking 1 here, 1, 1 at the end, 1 and 1 at the end. Okay, you know what is a plus b power 0? You know what is a power 0? A power 0 is 1 only. Similarly, a plus b is also constant. We get to see, say, for example, power 0 is also equal to 1. Okay, this gives coefficients of a plus b power 0. Okay, now is equal to a square plus 2ab plus b square. Okay, now by using Pascal triangle, how do you expand this a plus b whole square? See, very simple. From a and b, take a power 2, b power 0. Next, decrease the power of a, take a power 1, and increase the power of b, 1. Next, increase, that is decrease the power of a, that is 2, 1, then we get a power 0, and 0, 1, b power 2. Okay, that may be, if it is binomial, binomial, that is, bi means 2 terms. If you have 2 terms with the power 1, 2, 3, 4, etc., decrease the power of the 1 term, that is a, and increase the power of the second term. Okay, a power 2, a power 1, a power 0, etc. Then next b power 0, b power 1, b power 2, etc. Now come to the coefficients. Okay, this one. This is for a plus b whole power 0. This is for a plus b whole power n. Now for this one, take 1 plus 1. That is 2 only. Okay, 1, 2, 1 are the coefficients of the first, second, and third term in the a plus b whole square formula. And this is for, we use this one for a plus b whole cube. See, first term coefficient is 1, second term 1 plus 2 is 3, and 2 plus 1 is 3 and 1. That means we use this to expand a plus b whole cube. How do you write it? Take a power p, a power 3 and b power 0. Okay, next, a square, b power 1, a power 1, b square, a power 0, b cube. Okay, now what are the coefficients? 1, 3, 3, 1. 1, 3, 3, 1. Okay, therefore a plus b whole cube is a cube, b power 0 is 1. Okay, then we get a cube plus 3 a square b plus 3 ab square plus b cube. Okay, similarly, we can use this line. That is, first coefficient is 1, 1 plus 3 is 4, 3 plus 3 is 6, and 3 plus 1 is 4. We can use these as a coefficients of a plus b whole power 4, same as previous one. Okay, take a power 4, b power 0, next a cube, b power 1, a square, b square, a power 1, b cube, a power 0, b power 4. And what are the coefficients? 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Got it? Okay. Suppose if it is a minus b. In all the cases, if you take a minus b whole power 1, a minus b whole square, a minus b whole cube, a minus b whole power 4, etc. In place of b, take minus b. That's it. Okay. Suppose in case of a plus b whole square, a square plus 2ab plus b square. Okay. If it is a minus b whole square, take b as minus b, a square plus 2 into minus b plus minus b whole square. That is a square minus 2ab minus b whole square is plus b only. A square minus 2ab plus b square. Similarly, if it is a minus b whole cube, replace b by minus b, b by minus b. Then here minus b power 0 is plus 1 only. First term is a cube, and here we have minus b, minus 3a square into b. Here b, we have b square, minus b whole square is plus only, plus ab square. And we have a power 0 is 1, minus b whole cube is minus b cube. Okay, minus into b cube, etc. Okay, similarly for a plus b whole power 5, how do you find the coefficients? This one, 1 plus 4, 5. Next, 4 plus 6, 10. 10, 5, 1. Then how do you write a plus b whole power 5? Directly we can write a plus b whole power 5, a power 5, 1 a power 5 plus 5, a power 4, b power 1 plus 10, a power 3, b square plus 10, a square, b cube plus 5, a b power 4, okay, plus a power 0 is 1 only, 1 into b power 4, b power 5. Okay, like this we can use the Pascal triangle to find the coefficients of the power n for n is equal to 1, 2, 3, 4, etc. In general, if it is a plus b whole power n, okay, in this case, in general, take the coefficient as a c naught combination, nc naught a power n b power 0, okay, plus nc1 a power n minus 1, okay, reduce the power of a and increase the power of b power 1. Next, nc2 a power n minus 2 b power 2 plus nc3 a power n minus 3 b cube, etc. And the last term is ncn a power 0 b power n. But what about this nc0, nc1, nc2, etc.? See, nc0 is always equal to 1. Okay. Next, nc1 is n only. Next, nc2 is n into n minus 1 divided by 2 factorial. And NC3 is n into n minus 1 into n minus 2 divided by 3 factorial, etc. But what about NCN, last term, and NCN minus 1, NCN minus 2, etc. Okay, the NC1 is 1 only. NCN minus 1 is n, just the opposite to this one. See, NC0 value is equal to NC1, NC1 value is equal to NCN minus 1, NC2 value is equal to NCN minus 2. Then what is NCN minus 2? N into n minus 1 divided by 2 factorial. And what is its previous term? NCN minus 3. This is equal to NC3 only. That is n into n minus 1, n minus 2 divided by 3 factorial. Okay, this is about the binomial expansions. That is, by using a Pascal triangle, we can find the coefficients of the binomial theorem. Okay, and in the set of linear equations, we can find the cross multiplication. Suppose if we consider two equations, a1x plus a2y plus a3z is equal to 0, and b1x plus b2y plus b3z is equal to 0. These two are the two homogeneous linear equations. Linear means power of unknown quantities, that is x power 1, y power 1, z power 1. Here also x power 1, z power 1, y power 1. Okay, if we have 2 or 3 set of linear equations, then how do you find x, y, and z values? That is very important. Okay, to find the x value, y value, and z value, consider for x value, consider the coefficients of y and z, these 4 values for x value. Okay, find the determinant of a2, a3, b2, b3. Okay, by using cross multiplication method, we can find x, y, and z value. And for y, it is always negative, plus, minus, plus. Okay, now to find y value, okay, except this, to find y value, use x and z coordinates, these two. Okay, now a1, a3, b1, b3. And similarly, for z, to find the z value, consider, see, by excluding this, consider the coefficients of x and y, these two. Okay, what are the coefficients of x and y? a1, a2, b1, b2. Okay, by using this cross multiplication method, we can find x, y, and z values. Okay, but while finding the x, y, and z values, we should take plus, minus, plus, alternating sign. Okay, x is plus, y is a negative sign, z is plus. Okay, next, this are all some, I am explaining only the basic things. Okay, in depth we can discuss in the classroom. Now, you know the limits formula, only 2 important formula. Limit sin x by x as x tends to 0, and limit tan x by x as x tends to 0. What is limit sin x by x as x tends to 0? The limit, the sin x by x as x tends to 0 is
1.
always equal to 1. Okay, sin x by x as x tends to 0 is 1. Similarly, a limit tan x by x as x tends to 0 is also equal to 1. Okay? Now, if we interchange the denominator and the numerator, that is limit x by sine x as x tends to 0 is also equal to 1 only, and limit x by tan x as x tends to 0 is also 1. And if it is like this, limit sine square x by x square as x tends to 0, and limit sine cube x by x cube as x tends to 0. In all these cases, it is 1 only. But you know this thing, limit sine x by x as x tends to 0 is 1. But if the powers are same, x sine square x square, sine cube x cube, sine power 4 x power, etc., in general, limit sine power n by x power n as x tends to 0 is 1 only. Okay? Similarly, in this case also, in tan also, limit tan square x by x square as x tends to 0 is 1, and limit tan cube x divided by x cube as x tends to 0 is 1 only. In general, limit tan power nx divided by x power n as x tends to 0 is 1. Okay. Similarly, if you interchange these two, that is limit x power n divided by sine power nx as x tends to 0 is 1, and limit x power n divided by tan power nx as x tends to 0 is also equal to 1. Okay, got it? You know only in the second PU level, you know only these formulas. If powers are same, then also we get same value, sine power n and cos power n. Okay. Next one, open interval and closed interval. Open and closed interval. See, open interval means the notation is like this for open interval. Okay, closed interval, it is like this. This is open and closed. Okay, now I'm taking x is less than 3, greater than 2. Okay, here x value is excluding 3, excluding 2. That means 2 and 2 comma 3, excluding 2 and 3. This is your open interval. If it is like this, x is less than or equal to 3, greater than 2. Okay, if it is x is less than or equal to 3 means including 3. That means 2 comma 3, closed at 3, open at 2, excluding 2, including 3. And x is less than 3, greater than or equal to 2. Like this. If it is like this, then 2 comma 3, open at 3, close at 2. Okay, including 2, excluding 3. Closed means if x is less than or equal to 3, greater than or equal to 2. Okay, including both 2 and 3. All the values between 2 and 3 here. Open at 2, open at 3 means we have to collect all the values between 2 and 3, excluding 2 and 3. But in this case, collect all the values between 2 and 3, excluding 2, including 3. Okay. In this case, including 2, excluding 3. Collect all the values between 2 and 3, including 2 and excluding 3. Okay. Now, in this case, collect all the values between 2 and 3, including both 2 and 3. Okay. This is about your open and closed interval. But these two cases are open at one end and closed at the other end. Okay. Next concept is, next one is even and odd function. Okay. If it is even function, what happens while integrating, and if it is odd function, what happens within some intervals. But in these intervals, we have two types. Other than open and closed, we have like this: 0, A, or to A, minus A, comma A. Okay. Here, in the first interval, 0 is the end point, but in this interval, 0 is the midpoint. If it is like this, minus A to A, in between we have 0. But this is 0 to A and to A. 0 is the end point, 0 is the midpoint. Okay. If the interval is minus A to A, minus A to A, in this case, to check the nature of the function, we have to replace x by minus A. Nature of the function means we need to find either the given function is even function or odd function. Okay. In some example, we'll get neither even nor odd also. I'll give example for both the even, odd, and neither even nor odd. Okay. Suppose I'm taking f of x is equal to x. Okay. In this function, replace x by minus x. What happens? F of minus x is minus x whole square. Okay. F of minus x is minus x whole square. Then minus x whole square is x square only. F of minus x is x square. That means it is given function only. Therefore, f of minus x is f of x only. Therefore, given function, this function is even function. Okay. Next, after replacing x by minus x, for example, I will take f of x is equal to x cube. I am taking simple examples. Okay. If you replace x by minus x, we get f of minus x is equal to minus x whole cube. Okay. Then it is minus into x cube. That is minus into x cube is what? X cube is f of x only. Therefore, f of minus x is minus into f of x. Then given function is odd function. Okay. And similarly, I'm taking f of x is equal to x square plus x cube. Now replace in this interval only. Okay. In this interval only, replace x by minus x. Then f of minus x is minus x whole square plus minus x whole cube. Okay. Then it is minus x whole square is x square only, minus x whole cube is minus into x cube. Okay. Given function is x square plus x cube, but after replacing x by minus x, we get x square minus x cube. This is not equal to f of x or not equal to minus into f of x. Okay. Therefore, here this function is neither even nor odd. Okay, in the nature of the function, we have three types. The first one is even function, next is odd function, and other one is neither even nor odd function. Okay, but while integrating, what will happen? In case of even function, if f of x is even, okay, say for example, I will take f of x is equal to x square only. If you integrate f of x with respect to x from minus a to a, what happens in case of even function? And similarly, if f of x is odd function, that is, I'm taking f of x is equal to, say, x, simple example. X is also odd function, okay? Then integration from minus a to a, f of x dx is what? These two are very important. Okay. Now, in general, I am taking minus a to a. Now, I will integrate f of x, odd function f of x, from minus a to a. Okay. What is the integration of x with respect to x? That is x square by 2. Okay. In the definite integral, you will not get integral sign, minus a to plus a. In the definite integral sign, integral constant eliminates. Okay. Then we get only integration of the function and apply the upper and lower limits. If we apply upper limit, we get a square by 2. Okay. Upper limit is x is equal to a, put a square, then we get a square by 2 minus of. Put x is equal to minus a square divided by 2. Then simplify this, a square by 2 minus again a square by 2. This is equal to what? 0. That means if f of x is odd function, integration of f of x with respect to x from minus a to plus a is 0 in case of odd function for odd. Okay. Similarly, in case of even function, if it is like this, minus a to a, I'm taking x square only dx. Okay. If we integrate it, integration of x square is x cube by 3 and apply the lower and upper limit minus a to a. Then if we simplify, we get a cube by 3 minus a whole cube divided by 3. This is equal to a cube by 3 minus, this is again minus into a cube by 3. Then it becomes a cube by 3 plus a cube by 3. That is 2 times a cube by 3. Okay, this 2 times a cube by 3 can be written as 2 times integral 0 to a f of x dx. Okay, that means this integral minus a to plus a x square dx is 2 times integral 0 to a x square dx. Okay, if you integrate this 0 to a, what will you get? X cube divided by 3 from 0 to a. That is 2 times, apply the upper limit, we get a cube by 3 minus 0 by 3. Then it is 2 times a cube by 3. See, here in the previous in the previous step, see, minus a to a x square dx is 2 times a cube by 3. And if you write minus a to x square as 2 times 0 to a, then also we get a cube by 3. That means integral minus a to a f of x dx is 2 times 0 to a f of x dx if it is even function. Got it? If it is odd function, this is for even. For odd, integral minus a to a f of x dx is 0. This is for odd function. Okay, these two are very, very important formulas while solving the problems in the integral calculus. You will get integral calculus in the first semester, second, third, and fourth also. Okay, in all the subjects we use these two formulas. If it is even function, 2 times 0 to a. If it is odd function, 0. Okay, and next one I will give very, very important two formulas. Okay, very important formulas. Integral e power ax into sin bx and integral e power ax into cos bx with respect to x. Okay, while solving the so many problems, we use these two formulas. Okay, the standard form is integral e power x sin bx. If it is e power x, numerator is e power ax only. Here also e power ax. Denominator is a square plus b square. Here also a square plus b square. What is a? A is coefficient of x in the exponential function, and b is the coefficient of x in the trigonometric function sine. Similarly, in this case also, coefficient of x is a, and coefficient of x is b, a square plus b square. And this thing is multiplied with. In case of e power x into sin bx, first term is a sin bx. Same function. A is the coefficient of x in the exponential function into sin bx, this one. And here also a into cos bx. Got it? First term. Next, if it is sin, e power x into sin minus, if it is cos, it is plus. First term is a, second term is b. Here also it is b. And if it is sin, second term is cos bx. Okay, and if it is cos, second term is sin bx. Okay, got it? Okay, now with this I'm going to complete either 4 o'clock aita time aita 5 minutes idea. Sorry. With this I'm going to complete today's session. In this session we discuss with the how to write the straight lines, different parabolas and circles. In the circle, method of finding the lower and upper limits for x and y, and constant limits for x, variable limits for y, and variable limits for x, and constant limits for y, constant limits for x, etc. And some basic mathematical formulas, that is indices formulas, logarithmic formula, indeterminate forms, and some integral formulas. Okay, standard formulas, that is e power x into sin and e power x into cos, etc. Okay, I will continue with the same formula in the next session. Next session will be on Monday afternoon, 1:30 to 4 o'clock. Okay, in 1:30 to 4 o'clock Monday also, I'm going to discuss some basic things required for the engineering mathematics and the different subjects in the engineering. That may be computer science, information science, electronics, electrical, mechanical, civil. Okay? Okay, I'm conclude. Shall I end this? Now I'm going to end this session. Okay? Raghavendra,
Bye-bye.
dear students, if you have any doubt, you can, if you can clarify while coming to the college in the next week, 21st onwards, we have classes. In that class, I will clarify if you have any doubts. Okay?
Thank you, sir.
Now I will end this session. ಯಾರು ಇಲ್ವಾ ಅಲ್ಲಿ? ಆಯ್ತು, ಇದೀರಾ? ಏನ್ ಮಾಡ್ತಾ ಇದೀರಾ? ಬನ್ನಿ, ಹಿಂದೆ ಕೂತಿದ್ದೀರಾ? ನಾನು ಇದು ನಾನು ಹಂಗೆ ಮಂಡೇ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀನಿ. ಇದು ನಾನು ನನ್ನ ಹತ್ರ ಮಂಡೇ ಸೇಮ್ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀನಿ.
ಸಿಕ್ಕಾಪಟ್ಟೆ ಜಾಸ್ತಿ ಸೆಷನ್ ಸಿಕ್ಕಾಪಟ್ಟೆ
ಕೇಳಿದ್ರೆ ಸಾಲದು ಹೇಳಿದ್ರು. ಮುಗಿಸ್ಬೋದಿತ್ತು 10 ವರ್ಷದಿಂದ ಸುಮ್ಮನೆ
ಸಬ್ಜೆಕ್ಟ್ ಪಾಸ್ ಮಾಡ್ಬೋದಾಗಿತ್ತು.
ಹಿಂಗೆ ಮುಗಿಸ್ಬೋದಿತ್ತು ಎಲ್ಲಾ ಸಬ್ಜೆಕ್ಟ್ನು. ಇವನೇ ಬರ್ದ್ಬಿಡ್ಬೋದಿತ್ತು ಹುಡುಗರದೆಲ್ಲ ಎಕ್ಸಾಮ್ಗಳು. ನೋಡಿ ಎಲ್ಲಿದೆ ಏನ್ ಮಾಡಿ
देखते हैं नेपाली. Anyone are Nepali student भने ANUP ASATTA बाट
और पेज स्टार्ट होना है आज
नहीं.
हाँ
आज तक क्या